Hi everyone! Last video lecture, you learned about resistors and series, and this time we will be learning about what happens when resistors are connected in parallel. When we talked about a series circuit, there was only one path for the current to flow, but when resistors are connected in parallel, as you can see in the circuit above, the current has multiple paths to flow. When the current flows towards a junction, the current will flow in both the path towards the top resistor and the path towards the bottom resistor. This is what makes parallel circuits unique and different from series circuits. So now let's take a look at the total voltage for a parallel circuit. In a parallel circuit, the voltage remains the same across each of the resistors. This means that the total voltage of the circuit is the same as the voltage across each of the resistors connected in parallel. So V total is equal to V1, V2, V3, and so on. Let's take this circuit as an example. Two resistors are connected to a 12-volt battery in parallel. The total voltage of the circuit is 12 volts. Since the resistors are connected in parallel, the voltage across resistor 1 is also 12 volts, and the voltage across resistor 2 is also 12 volts. Now let's talk about the total current in a parallel circuit. As we showed in the earlier diagram, what makes a parallel circuit unique is that the current splits into different paths at each junction. When the total current of the circuit approaches the junction, it separates into current 1, which will flow through resistor 1, and current 2, which will flow through resistor 2. Since the current in a circuit must be conserved, we can come to the conclusion that the total current is equal to the sum of the current that passes through each resistor. Finally, total resistance. Total resistance has the most interesting formula compared to the others. First, let's suppose we have a circuit as shown to the left. As we previously discussed, the total current is going to equal the sum of the currents through resistors 1, 2, and 3. Ohm's law states that voltage is equal to I times R, which we can rearrange so that it says I equals V divided by R. We can then use Ohm's law to rewrite the current in terms of the voltage and resistance. So I1 plus I2 plus I3 becomes V over R1, V over R2, and V over R3. Next, because voltage is the same across each resistor connected in parallel, we can factor out V, and what we have left is the total resistance of the circuit. This means that the formula for the total resistance is equal to the reciprocal of the sum of the reciprocals of the resistors. A lot more interesting than the other formulas, isn't it? Here's a summary of the formulas we just covered. Please be sure to copy these into your notes and formula sheets. Now, let's try a practice problem. Here's a circuit with 3 resistors of resistance 10, 15, and 30 ohms connected in parallel. Find the total resistance of the circuit. This problem is very straightforward, and all we need to do is plug in the numbers into our formula for the total resistance. So our total resistance is equal to the reciprocal of 1/10 plus 1/15 plus 1/30. This gives us a sum of 1/5, which when we take the reciprocal of it, gives us a total resistance of 5 ohms. Notice how the total resistance of resistors connected in parallel is less than the resistance of any one individual resistor. This is another unique aspect of parallel circuits. Now, let's find the current that passes through each resistor. Since the resistors are connected parallel to a 60-volt battery, what is the voltage across each resistor? Yes, the voltage for all of them is 60 volts. So how does this help us solve the problem? Well, since we know both the voltage and resistance for each branch of the circuit, which law do you think will help us? If you said Ohm's law, you're right. We can use Ohm's law for each branch of the circuit. So for the first branch, 60 volts is equal to the current times 10 ohms, which gives us a current of 6 amperes. Using Ohm's law for the second branch gives us a current of 4 amperes. And for the third and final branch, Ohm's law gives us 2 amperes. Now, what is the total current of the circuit? Well, there are two methods that we can use to solve this. For method 1, since we know the total current in a parallel circuit is the sum of the current through each branch, and since we found the current through each resistor in the previous problem, we can simply add up the currents. This means the total current is 6 plus 4 plus 2, which gives us a total of 12 amperes. The second method that we can use as well is Ohm's law. So the total voltage is going to equal to the total current times the total resistance. Since we know the total voltage is 60 volts, and we calculated the total resistance to be 5 ohms, we can plug this into the formula. This also gives us a total current of 12 amperes. Thank you for listening to this video lecture, and I hope you found parallel circuits to be fun.